Hi, everyone. Super excited to be here and talk about something that I'm very passionate about and I've been building for a while now. So today's agenda, I'm going to give you a little bit of a background into where we are coming from to today's world where we have large language models. We will talk about some of the challenges of operationalizing this type of models. Then we will go into deploying and the tool stack and techniques. And I'll give you a demo. Hope it goes right. So who am I? I'm an MLOps engineer, and over the years I've contributed to a few projects, and I worked at Neptune AI, and these are some of the integrations or systems that I've contributed to in the MLOps and ML landscape. With that said, before we can talk about the future and the present, we have to revisit the past. And it's a bit ugly, but we will be happy we did it. So back in the day, which now seems like it was yesterday, we had a deep learning training pipeline. And the early pipeline we had two stages, training and fine-tuning. So within the training part, we gathered, or researchers gathered, data within a narrow domain, and then they trained those models because they had the resources, the GPUs, and pretty much released it onto the public or open source space, and we would pretty much take the model and customize the final layer so that it would fit into our even narrow domain. A great example of this is image classification. I believe most of you here might know ImageNet 1000, where we had a model that was trained with 1000 labels. But when you want to deploy this type of model to production, you come into a problem where this model has just way too many parameters that you don't need. Perhaps you only want to classify people or dogs, so the 999 parameters are useless for you. That's why we fine-tune these models. Usually, in terms of like resources, you would need about 2 to 8 GPUs back in the day. This was unfeasible for most people or companies, so that's why researchers did it. And nowadays, it's pretty much easy to do this. And fine-tuning, it's super easy and cheap to do. Moving to today's era, the era of foundation models. This type of models are different from what we used to do. So before, we had to adjust the network. We had to pretty much know how to create a custom network and fine-tune to our use case. These models are pretty good within a broad domain, meaning they don't need to be customized in terms of architecture or architectural wise. What you need to do is to find data or collect data for your particular modality. So today, I believe most of you know GPT or ChatGPT. Those type of models are pretty much what we consider large language models, and they are very, very good within the text domain. But they could also be multimodality models or multimodals. These type of models are good across a variety of modalities. Here we have vision, structured data, and speech. And I believe with the recent OpenAI Dev Day, they released the model with both vision and the other one with speech. That's just an instance of what multimodality is. And still, pre-training this type of models is right now expensive and unfeasible. I don't know if you saw the quotas for GPT-4 fine-tuning. That takes a few $1 million. So most companies are pretty much out of the race. But the big labs or big research firms can pre-train these models with the whole of the internet's data, terabytes upon terabytes of data. And then we have a model or a foundation model that's pretty good within that domain. And usually these models are pretty good for 90% of the companies. Like, you can take this pre-trained model and use it right away. But you might think, well, my use case is a bit different. I need this model to behave a certain way. This is where domain adaptation comes into place. And there are a few ways you could go about this. The first way and it's the classical way, is fine-tuning, but I wouldn't advise majority of the companies, or pretty much 99 or 95% of the companies, to do fine-tuning, because it's still very expensive to fine-tune this type of models. On top of that, you need to have proper data or a large enough data set within your domain. And most companies don't really understand what type of data they need to kind of feed into these models to create a good experience. The path that majority of startups or AI startups that are coming up are using is prompt engineering and retrieval. So prompt engineering, as it suggests, you prompt the model to behave a certain way or to take certain actions, and usually because of the pre-training phase and pretty much reward modeling and reinforcement learning with human loop feedback, these models are very good at following your prompts. So with just prompt engineering, you can persuade the model to behave a certain way. And this can help us achieve our final goal here, which is our downstream task. Usually you would have like question answering, image captioning, code completion, and data extraction, and so on. And another way of adapting these models that it's pretty much became mainstream, I remember talking about this back in 2018, which is RAG, Retrieval Augmented Generation. So the way this works, you still prompt the model, but now you pass in context relevant to your particular documents, or if you have a particular data source. You pass that into the prompt along with your initial instructions to the model, and the model will be able to behave the way you want, thus pretty much adapting to the downstream task. Now, what are some of the key challenges that we have with large language models, or even just foundation models in general? First one is model size. These models are very, very large. We are talking billions of parameters. A small model with 7 billion parameters takes about 14 gigabytes of RAM to run. So storing and loading these models to memory is just very, very expensive, which brings me to infrastructure costs. Having access to specialized hardware, because these models run on specialized hardware, GPUs, TPUs, and so on, is very hard, especially nowadays where we have only a few players within the hardware space. Another one is latency. So because these models are big, they might take a lot of time to run the inference, and we want to give feedback to our users right away. So that's where things like streaming come into play that makes the whole experience better. So latency is a big factor here that you have to keep in mind. And the last one is scalability. Be able to scale with the load whilst maintaining the performance of the model. That's a big, big thing. So you might have a good model that has all the above, but if your model performance degrades whenever you have a spike in usage, that's going to be a big problem. So for this next part, we have a challenge, and I hope you join me on this challenge, where we are going to deploy a large language model to production in under $100, and we will run inference just to check. Who believes this is possible? You raise your hand. Okay, wow, you guys are optimistic. Okay, so how do you deploy and scale these models in production? There are a couple of ways you can think about it. Your traditional software engineers and platform team members are thinking Kubernetes containers, just containerized and ship it to production. That's the way it will scale. We will have no problems. But if you think about majority of the companies, they don't have a platform team. They don't have a software engineering team. And they don't even have the resources or infrastructure to kind of build these things. Yes, they could use cloud, but it would still require them to hire special talent to be able to manage this infrastructure. So this is not the right way to do it. There is another way though, and this is where I started experimenting earlier this year. I thought, okay, there are a couple of things that are important for me. First, I need an optimized library for inference, making sure that I get the best inference possible. Second is latency. It has to be able to provide me streaming right out of the box. And then infrastructure management. my team is pretty small. We don't want to manage Kubernetes clusters or anything like that. We want a system that provides us pretty much scaling and infrastructure management, and it's also on demand right away. And finally, we will be able to scale, and cold start times should be reasonable. So the stack I chose initially was Hugging Face, AWS Lambda, Fast API, and Docker. But there were a couple of problems that I faced. The first one is with the optimized inference. Hugging Face is really good. Transformers from Hugging Face is really good, but it's not properly optimized for inference. It's great for training and customization and so on, but inference is a big pain in the ass. So then we have latency. I found out earlier that AWS Lambda, and I actually reached out to them and I said, hey guys, why don't you have Python runtime token streaming? They were like, well, it only works for JavaScript at the moment. We are trying to get that on board. And I was like, okay, I can forgive them for that. But later on, I found out that their cold start times are very sporadic. It varies between 100 milliseconds to 25 seconds. I never really know where the system stands. So this is where I decided to take a different approach. I kept on experimenting and I landed on this stack here. First, I tried to experiment with other libraries like TGI, but TGI is not non-commercial. Then I found out about vLLMs, which works like magic. Of course, it's arguable today, but when they started, they were like the best in terms of optimizing inference. And then I have Langchain, which is a framework for building large language models. It helps me with very usable abstractions for prompt engineering and retrieval augmented generation pipelines. Then I thought about, okay, in terms of infrastructure, I tried a few, but I landed on Modal because Modal gives me access. Pretty much I can work the same way I already work, which is with Fast API right out of the box, and they already have token streaming that just works with Fast API. On top of that, they are serverless cloud compute platform, and they provide both CPU, GPU, and also in some instances you can also augment your infrastructure with memory. So that's a plus. I can rent GPUs whenever I need it, and I don't need to pretty much pay for times that my system is not being used. And finally, it can scale really well. And the cold start times for Modal, at least when they started, and I kind of been monitoring this, is around 1 second. So my users would forgive me, and actually 50 plus of those users forgave me and joined my platform. So now it's demo time, and we all know that demos are witchcraft, but let's try and do it the right way. Here's a bit.ly link for the code if you want to follow along or you want to later on check it out. I'll give you a second just to get that link. All right, so let's start here. What are you looking at? Here, you're looking at a Python script. I don't know, can you guys see it properly? Okay, fantastic. So here you're looking at a script that deploys Mistral 7b instruct to production, and we run batch inference on two samples. So what am I doing here in the beginning? Here in the beginning, we're just downloading that model to the machine using Hugging Face Hub. Then the most important part that you should see here is this part here where we are creating an image. The thing with Modal, they redefined Docker containers. So they pretty much stripped down everything and created their own version of Docker containers. That's how they can keep the inference very, very fast and cold start times pretty much reliable. So you build an image very simply here. You can choose an image from a public directory. Then to install your libraries, you just use the convention, this method here, pip install. And here I'm just installing PyTorch, installing vLLM, Langchain, and a few other libraries. And finally here, you can see this run function, meaning once my image is installed and I install all the libraries, I can actually just download the model when the container is being built. So the model already lives within the container. You don't have to download it again from Hugging Face Hub. This makes things even easier to work with. Then you create a stub. A stub in Modal is a way to interact with your functions and your classes. It's just an abstraction that Modal has. And you pass in here the image. Now, this is where I knew that Modal was right, at least for me, because within this single Python script, I can provision GPUs to a particular function. Instead of providing GPUs to my entire container, which would be not properly used because I'm only running inference in a particular part of my code, so I don't need to have GPUs running at all times. So here I can create a function called inference and just provision a A100 to that particular function. And here is as simple as just vLLM from Langchain, passing in where I store the model and some parameters. And here's where I just run the batch inference using Langchain abstraction for vLLM. And these are just the user questions, and I print the results. This is where this is your entry point for your container. So whatever is in here, it could be also a fast API application. This is how Modal renders stuff. So in this case here, I just have a main function that passes in what is the capital of France and what is the capital of Italy. And I just call that function I created that has the GPUs, and I just do .remote and pass in the methods. And that's enough to provide me the answers right here. And you might think, okay, Prince, you talked about this being serverless and costs. How does the cost look like for this type of inference? So we can come back here. I'll just quickly show you here. This is the function, and you can see here by the name, demo Langchain Huggingface vLLM inference, and it only cost me 0.06 cents to run actually 2 inferences. So I'm paying by the second, and it's consistent. You can choose to pay by the hour, but by the second makes a lot of sense for my use case. And here you can see where the GPU was used and where the memory and CPU were used. So going back, you can also provision more RAM for your particular instance or more CPU, depending on how you want. So this stub function here allows you to pass a lot of different things. So you can pass in GPUs, you can pass in even storage. They have something called shared volume where you can use to store big artifacts. And you have memory and CPU and other things. So this is how we run inference in production pretty much, because you can just do models serve or deploy, and this particular script will be containerized and shipped, and it will auto scale for you automatically. You don't have to do anything else. So another example here, I just showed you batch inference. Another example is token streaming, which was the main point that I was talking about earlier. So here I'm using, it's the same structure. The difference is instead of I'm just using the defaults. I'm not passing in any GPUs because I'm using OpenAI. And I'm using OpenAI GPT 3.5 Turbo. And the way I do all of this, you can just see here, I can stream the response from my function, and this is going to provide me everything I need. And the way I built this particular example is I built it as a endpoint, a fast API endpoint. So you can see here that this is where I instantiate the fast API application, and this is how kind of Modal takes it. It recognizes it as the ASGI app. That's how you create your fast API. Now, for the example of this, you can see here that we can actually just send a request again. Okay, it's no longer running. I need to run it. That's pretty simple. Here, control finish. And there we go. Modal serve, and I just pass in the script. Now we can come back here and make the request, and you will see that it will start streaming the response. And this is how Postman streams the responses. There we go. So you can imagine that you can connect this to a front end and then stream those responses to the front end, and you will be able to kind of decode them or aggregate the way you want. So that's an example of streaming responses. But Modal could do so much more. Modal could do so much more. You can use it for training, fine-tuning models. So this is not only for cases where you want to deploy your systems. You can actually use this as a service to provide you with the resources for you to build your own custom machine learning workflows or large language model workflows. Their docs is great. And by the way, I'm not affiliated to them. So I'm just a happy user, and I've been using this for a while. I'm excited to talk about it because it's so hard to find infrastructure to build with large language models instead of just depending solely on OpenAI, which actually this last week was a great example of why relying on a single provider is a big issue. So if you go open source as well, with things like Langchain, you can create what we call fallbacks, where you can first, of course, make the request to OpenAI, and if OpenAI is down, Langchain will automatically route your request to your particular custom model. In this case, you have your Mistral instance. You can just route the request to that instance, making sure that your users are always served, no matter what happens to the providers. So, a few key points to take away from this talk is first, make sure that you find ways to optimize your inference. Yes, you can take models out of the box, but if you can squeeze performance out of it and you can find ways to optimize it, do it right away or experiment with it. It doesn't have to be in the first deployment, but over time you might want to get those performance gains that are on the table. Second is find infrastructures that abstract all the daily things, scaling up or down or managing containers. This helps you move fast, or even if your team is very engineering focused, you might think, well, this is good for a POC. Well, start there. If you want to build on your own, sure. But these guys are well funded and they just built something pretty awesome. And I believe in standing in the shoulder of giants. That's why I believe in finding ways to take away the load that is not your core business use case. If your use case is not being OpenAI, find ways to abstract stuff and move faster. And finally, modularity is key. Everything that I talk about here is modular. So you can replace any of this systems or libraries and choose your own. So you can replace Hugging Face with raw PyTorch or TensorFlow. It's up to you, but it all works in a way that you are first not vendor locked. Second, you're not depending only on a particular API or company. So you can build a robust production pipeline. And that's it. Please feel free to give me a feedback.
Thank you very much.
Any questions? Awesome.
Hello, I have a question about Langchain because
Sure.
I've heard that this is like very good solution if you want to switch model quickly, but also I've heard that it has a lot of bugs and things to fix. And my question is if you think it is stable or for what don't use it because you can have problems.
So actually I was talking to the founder of Langchain way before ChatGPT, and he explained to me how it is. Of course, indeed, in the beginning, they were trying to build quickly, so they build a lot of things. But the good thing that they just released recently, if I remember correctly, you can actually just download particular packages within Langchain that serve your use case and make sure that those remain static. At least that's how I'm doing it. I'm not using the latest because they're still building. So there's going to be a lot of problems, and they build really fast. So meaning after the same day of a release, they already make their own abstractions. That's good, but also could be bad if you're running production. So make sure you pin the versions and download only the things that you need. Of course, you can also look at the source code and gain inspiration from that. That's how I've also built my pipeline. I don't follow everything they do. I like certain things, so I just take those things and create my own. Any other questions? Awesome.
Okay, first of all, thanks for the presentation.
Most welcome.
My question was, do you know any alternatives to Modal, especially for these giant cloud providers?
Yes.
Because I have encountered many times that clients don't want their data to escape from their cloud.
Yeah, I understand that. That's a common concern because of data laws and etc. So there are a lot of providers. Amazon released their own version of this, which is Bedrock. There is also alternative to Modal. I was also looking into Banana Dev. I know it's a weird name, but they also provide such infrastructure. And there are many other startups doing this because they're kind of building different things, but at the end of the day, they provide you resources to do this. There are a lot, but the ones that I know that are prominent are Hugging Face inference endpoints, Amazon Bedrock, Modal, Banana, and probably there are a few others, but if you reach out to me on Twitter, I can make the list and send it to you.
Thank you very much for presentation. So at the end, you highlighted that modularity is a key. So
Yes.
I'm interested how you would implement taking modularity in mind. Vector database for the information retrieval, knowledge retrieval, or just, let's say, caching what has been asked, and not to ask again or retrieve this information. Thank you.
That's a really good question. You don't know how timely that question is because just this week I decided to switch providers for my vector database. Initially I was using Pinecone and I saw that they're not everywhere. I want to move my production to kind of JavaScript workflows because I can leverage things like edge functions which run way faster. You can easily switch. The only thing that you have to know is that there's a bit of a learning curve, especially around vector databases. The idea that I would go with when it comes to kind of retrieval augmented generation is making sure you build a pipeline that doesn't rely solely on a particular feature of a particular vector database. So Pinecone initially I chose because of metadata filtering, but right now there are other offerings that provide the same thing. Of course, in the beginning, this is very new, so there was no other choice. But now you have a lot more options. You can choose from a myriad of things. I think Superbase is doing something really cool with the PG Vector, and they actually have a use case where they show that it's faster. So build it in a way that you can easily switch, but think about from a high-level point of view, how you want to build your pipeline. What are some of the things that you want to do in terms of processing and storing, and make sure that the way you store, the way you organize things, it could be ported across systems. Yes. Any other questions? I don't bite.
Thank you for the presentation first.
Awesome.
So if I understood correctly, in the example that you were showing, the model fit into the single GPU memory. So how would you approach that if you would have to deploy a really large language model, which would require several GPUs or maybe several machines?
That's a really good question. So you can just scale your needs according to the model you want to fit into memory. So you saw that Modal you can provision for your particular system. But the way this fit into a single GPU is because I also looked for inference gains, meaning using something like vLLM that optimizes inference. So you want to find the balance there. Sometimes the model is just too big for you to fit into memory. So that's when you should look at advanced techniques like quantization, pruning, and so on. But initially, I think you just find these libraries like vLLM, TGI, and so on, find ways to optimize your model without going into advanced stuff like quantization. If you can avoid it because it's very hard to quantify the kind of accuracy loss, and it will require you to be more, to build more robust evaluation pipelines. Of course, if that's something you want to do, for sure, go ahead, but like start small and then iterate from there. Questions?
Hi.
Hi.
So first of all, I really enjoyed the idea that you can deploy an LLM for $100. But apart from that, speaking about cost, when you first start and make a POC of your app, this solution, the model, can be actually enough. But then when you actually scale up, you might run into some problems. And so my question is that what would be the first signs that maybe your application is just big enough to explore some other options, or what is the first shortcoming of Modal that you will see?
Okay, that's a really good question. So the first shortcoming would be, of course, you wouldn't be able to have access to more resources because they have finite resources. It's not like they have infinite resources. So you would start hitting those limits, and your application would start to break in certain places, and you would notice that. But that's a really good question, and I spoke about this in a previous talk I did last year. It's called reasonable scale MLOps. The way you should think about this is most companies are not doing hyperscale MLOps, meaning they're not Google level, NVIDIA level, and so on. They're doing basic machine learning, and they don't have a lot of resources. So think about your revenue. How much money are you making from these models to justify the investment? If you're not making millions of dollars or hundreds of millions of dollars, there are certain things you can't justify. Even though it would increase the user experience and so on, you have to kind of quantify a lot of things. So think about team size, meaning your team to manage this infrastructure that you want to build that's customizable. Think about pretty much revenue. That's another big one. And think about data, right? Can you handle that volume of data? Because you now not only have data from your model, but you have data from the entire system that's a living, breathing system. So if you can scale in all those different areas, then perhaps you can think about going to the next level. Questions?
Perhaps I'm loud enough. Thank you. Hi. Hi, thank you for the presentation. I'm an infrastructure guy rather than an ML guy, so I have a question. What do you think is the one feature that you're missing in all those ready, fancy solutions that allow you to abstract from the classical infrastructure, like you mentioned, the Kubernetes with Dockerization and all that?
What is one feature that I'm missing?
Yeah, that you'd love to have. But there isn't there. There isn't one there.
I think right now is the problem that I noticed personally is just that these platforms have limitations. For example, limitation in terms of data transfers. So you can't transfer a file that's bigger than 16 megabytes and stuff like that. And there's no way around this, or there are no ready-made abstractions to be able to do this kind of aggregate or work around this particular issue. So that's one thing that I've been looking into, and I'm like, well, I wish I had a way to do this that didn't require me to create custom code just to kind of find work around this particular area. So data transfer is a big issue when it comes to platforms like this because they have those limitations. mostly because they rely on other providers under the hood, I believe. So I think as they scale, they might get better, but at the moment there are limitations like that that really kind of hurt the developer experience. Hope I answered your question. Yeah.
Okay, we still have time for one question. Okay, so if there are no more questions, then thank you very much again.